Okay, I've been asked to do a couple of problems on standard temperature and pressure and problems involving molarity. So here goes. Let's take a look at this first problem right here. Here's what it says. It says calculate the number of grams of hydrogen gas required to make 4.52 liters of ammonia at STP. So the first thing we want to do is we want to circle what we know. Obviously, the old number in the problem is the 4.52 liters of ammonia. And it says calculate the number of grams of hydrogen. So I'll just underline grams of hydrogen right there. So we know what we've got and we know what we're looking for. We've got the 4.52 liters of ammonia, and I wrote that right underneath ammonia in the correct unit. That's liters, 4.52 liters. And I'm looking for the number of grams of hydrogen. I want to know how many grams of hydrogen is going to be required to produce that 4.52 liters of ammonia gas. So how do I proceed? Well, the same way as I've always done, I write what I know. 4.52 liters, I'll put that right here, 4.52 liters of ammonia over 1 to hold that place. Whatever unit is in this position here, just the unit, not the number, whatever unit goes right there, goes right there. So if liters of ammonia is right here, liters of ammonia goes right there. I'll cancel those two. Now remember, in order to get into the kind of mole vernacular that our balance equation requires, I'm going to need to convert to moles. Now here's what you need to know. That at STP, at standard temperature and pressure, standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere of pressure. All gases have the same volume, including ammonia. So ammonia has a volume of 22.4 liters. 1 mole has a volume of 22.4 liters and 1 atmosphere. That gets me into moles. It's not moles of hydrogen, but at least it gets me into moles. So now I've got moles of ammonia. The next thing I'm going to do is I'm going to write the unit that I've got here, which is moles of ammonia, right there, moles of ammonia. So whatever unit goes in the upper left goes in the lower right. I'm going to do a mole to mole bridge right here using my balanced reaction. I have 3 moles of hydrogen gas being required to make 2 moles of ammonia. 3 moles of hydrogen gas to make 2 moles of ammonia. That's the mole to mole bridge right there. I'll cancel this unit with that unit and I'm left with moles of hydrogen gas. I'm not quite done. I'll look to see what I'm being asked for. I'm not being asked for moles of hydrogen, but grams of hydrogen. So I just need to make a quick calculation. 2.02 grams of H2 per 1 mole of hydrogen gas. Just add up 1.01 plus 1.01 from the periodic table for hydrogen. That's the molar mass or the atomic mass for hydrogen. And I get 2.02. I'll cancel this unit with this unit and I'll ask myself, am I looking for grams of hydrogen? I am looking for grams of hydrogen, so I'm done. Get the calculator out and start punching numbers in. 4.52 times 3, hit the enter button, times 2.02, hit the enter button again, divided by 22.4, hit the enter button again, divided by, not multiplied by, 2 is on the bottom, divided by 2, hit the enter button again, and we get this number, 0.61141107. 3 significant digits here, this doesn't count, 3 here, this doesn't count, that doesn't count. Those are exact numbers in the mole to mole bridge. That's 3 significant digits. I can only have a total of 3 significant digits. The leading 0 doesn't count, only the 0.611 counts because the 4 is not big enough to push this one over. So I have as my final answer 0.611 grams of H2. And I'm done with the first problem. Okay? Let's take a look at this problem right here. It says how many grams of zinc are required to react with 8.25 milliliters of a 6.0 molar hydrochloric acid. Now there's a lot of information here, but we want to kind of calm ourselves down, get a balanced reaction and go from there. This is a single replacement reaction. Zinc plus hydrochloric acid yields zinc chloride and hydrogen gas. The balanced reaction is 1 to 2 to 1 to 1. That's 1 to 2 to 1 to 1, mole to mole to mole to mole. Now let's write what I know underneath the balanced equation. They tell me that I have 8.25 milliliters of a 6 molar hydrochloric acid solution. I'll write both of those pieces of information underneath hydrochloric acid. 8.205 or 8.25 milliliters of a 6.00 molar hydrochloric acid solution right under the hydrochloric acid. I'm being asked for grams of zinc, so I'll underline that much and say question mark grams. That's what I'm looking for. I want to know how many grams of zinc are required to react with this 8.25 milliliters of a 6.00 molar solution. So where do I start? Well, the same place I've always started, and that is with what I know. In this particular problem, they're telling me that 8.25 milliliters of hydrochloric acid is what I'm going to start with. So I simply write that over 1. 8.25 milliliters over 1. That's hydrochloric acid over 1. Now I'm going to have to take a little bit of a detour here because I've got to get milliliters into liters. Remember, milliliters will never do. You've got to get it into liters. But that's pretty easy. Milliliters into liters, there's 1,000 milliliters in 1 liter. Whatever unit is in the upper left goes in the lower right. That will cancel these two and leave me with liters of hydrochloric acid. Now I'm not anywhere near where I need to be, but at least I have it in liters. Now what I'm going to do is convert to moles. I'm going to use the molarity to help me do that. 6.00 molar means 6.00 moles per liter. That's what molarity means, moles per liter. So when you see that capital M, it means moles per liter. And I can take advantage of that in this conversion right here. Liters of hydrochloric acid here, so I have liters of hydrochloric acid here. Moles of hydrochloric acid is what I'm looking for. This will cancel with this. 6.00 moles of hydrochloric acid then per liter of HCl leaves me with moles of hydrochloric acid. Now, I've got to go now from hydrochloric acid to zinc. This is the mole-to-mole bridge that I'm going to execute right there, from here to here. Whatever unit is on top, in this case it's moles of hydrochloric acid, is going to go on the bottom here, moles of hydrochloric acid there. Whatever unit I want goes right there. It's moles of zinc. So moles of hydrochloric acid on the bottom, moles of zinc. Well, what is that relationship? 2 moles of hydrochloric acid, so 2 goes next to there, to the moles of hydrochloric acid, requires 1 mole of zinc, so 1 goes next to the mole of zinc. Now what I've done is I've got my expression in terms of moles of zinc. I'm almost there. Remember, I'm looking for grams of zinc. So now I've got to go to the periodic table, and when I do, I find that 1 mole of zinc has a mass of 65.38, that's 2 numbers to the right of the decimal, grams of zinc. So I'll cancel this with this, and I'm left with grams of zinc. Is that what I'm looking for? It absolutely is what I'm looking for, grams of zinc. So I'm done. Get the calculator out and multiply 8.25 times 6.00 times 65.35 divided by 1,000 divided by 2, and I'm done. I get this number, 1.618155. That's too many significant digits. I've got 3 here. This doesn't count. These are exact numbers. 1 liter is exactly 1,000 milliliters, so that doesn't hinder me. We've got 3 significant digits here. Both of those zeros count, so 6.00. So 3 here, 3 there. That doesn't count. That doesn't count. That doesn't count. That does count. That's 4. But 3 is less than 4. I can only have 3 significant digits. So what I'll do is I'll underline the first 3 numbers and look to see if that next number is enough to push that 1 over. It's 5 or bigger. It pushes the 1 over, and my answer is 1.62 grams of zinc. I'll see you on the next video podcast.